In this video, we're going to talk about how to identify functions from a graph rather than just a list of points. And we do have a slightly different strategy here, although we could still apply the same idea from our relations of does an x value repeat. But there's also a visual test that's pretty handy. So what we're going to look at here is anytime you have a graph and you want to know if it represents a function, we're going to determine if it passes the vertical line test, which we can choose to represent using the letters VLT for short. So this is something you should have heard about in the past, but in case you've forgotten, pretty simple concept here. The whole idea is if you are able to draw a vertical line, so if a vertical line intersects a graph in more than one point, then the relation is not a function. And the idea here is we want to know if a graph is a function. We don't want to try to keep it a function. We want to do a full investigation. So for the vertical line test, what you'll do is you will scan to see if there is any place that you can draw a vertical line and touch the graph in more than one location. If you can, it's not a function. If there's nowhere to do that, we'll be satisfied that the graph does represent a function. Now we're still going to talk about the domain and range, and it is similar to what we said before. Your domain is still your x values, but with a graph, there's an infinite number of x values that you could have. You have your whole numbers, your integers, decimals, fractions. It's impossible to list every single x value on a graph. So what we do instead is we talk about how far, what interval of x values do you have? What's the lowest x value to what's the highest? And very similarly, we'll say the range is the included y values. So just like before, we're going to state all the different x values and all the different y values that occur. It's just we're going to describe the range of them because there are just too many for us to list. So looking at these examples down here, when we talk about a graph, we're not talking about the grid. We're talking about the portion of the graph that we plot with points. So in number 5, the graph that we refer to is this red circle. In number 6, the graph is this green parabola. And in 7, the graph is this entire orange parabola that's opening sideways. So let's make sure we're on the same page here. Graphs are what we plot with points. It's not the grid that you are viewing. Okay, so let's start off with the graph of the circle here. A circle is a closed object. It does not continue going on in any direction. So we can talk about our domain and our range here, where domain is your x values and your x-axis, remember, goes from left to right. So here is our x-axis, the horizontal axis, and similarly, our y-axis is the vertical axis. So to talk about our x values, we try to find the lowest x value. So on your circle, what's the farthest to the left it ever goes on the x-axis? And that would be this point over here at -2, 0. So which of those is your x value? That would be -2. So my domain is going to start with -2. And then we talk about what's the highest x value that gets used. Well, that would be over here, the farthest to the right on the x-axis, this point that has an x value of +2. So our domain will be all x values that are between -2 up to 2 and including those two numbers. So to show this range, we're not going to use this domain, we're not going to use braces. We're going to use what's called interval notation. And I'm going to put a bracket around this number and this number. And what that means is our domain uses all x values from this number up to this number. Okay, so let's do the same thing for our range. Our y values follow the y-axis vertically. So your lowest y value on this circle is way down here, and that y value is -2. And our highest y value is up here at this point, which has a value of +2. And just like we did for our domain, our range is an interval. So all y values from -2 up to +2 were used, even the decimals and fractions. As for being a function, we're going to say no. An example up here is this vertical line that touches the graph in 2 different places, and the reason is we fail the vertical line test.